Hey everybody, so now we've got some clouds, some land, some mountains, and a ship, and so we can look at some of the things that we went over this week in terms of scrolling and in terms of a generative landscape. And it's important just to reiterate once again, there's more than one way to do anything that you want to do. I'm just showing you one possible way to do it and introducing you to some of the concepts in the game. Of course, the important destination that we're headed towards is for you to be able to realize something of your own, something creative, by not just by learning the techniques that I'm showing you, but allowing those techniques to help you understand the environment and then take it in the direction that you want. So let's start with some sky, and we'll just make that a nice blue sky. And I'm going to put it into my scene so that it covers the whole background. And now I'm going to do something a little bit different. I am going to have this sky perform game functions. In the past I've showed you creating a separate game functions actor, but any actor can perform game functions. And in this case, I'd like the sky to create the clouds. So first I'm going to make a cloud actor, and I'm going to give that cloud a behavior of movement to the left. And I will have the sky periodically, using a timer, every 1 second, spawn a cloud. Where? I'll spawn it off the screen to the right. So looking back, my cloud is 100 pixels wide. So if I want it to be all the way off the screen, I'll need to spawn it at an X position of game display size width plus 50. Why plus 50? Well, my cloud is 100 pixels wide, and the cloud's X position is measured from its center. So from its center to its left edge is going to be half its width, or 50 pixels. So if I spawn it 50 pixels off the right-hand edge of the screen, then I know it will come to life off the screen. It would also be fine to spawn it a little further off the screen just to be safe, but minimally it needs to be 50 pixels off the screen. And I will spawn my clouds at a random location between the top edge of the screen, which is game display size height, and let's say halfway to the top of the screen, which is game display size height divided by 2. So clouds will appear in the top half of the screen. Game display size height divided by 2 being the minimum value, game display size height being the maximum value. And these positions will be relative to the scene. And I get a whole bunch of clouds. So what's a little unpleasant about this is the clouds are coming at such regular intervals. How can I make that a little bit irregular? Well, this is where we looked at that idea of percentages. I can change an attribute. What attribute? Well, I'll create a new one. I'll call it chance of cloud. I'm going to change attribute chance of cloud to a random number between 1 and 100. So why do I choose a random value between 1 and 100? Because when we think of a likelihood of things happening, we talk about the percent chance of them happening, and percent literally means per 100. There's 100 cents in a dollar, so per cent is per hundredth. So if I say there's a 40% chance of a cloud appearing any given second, I can create a rule, put my spawn actor inside that rule, put that rule inside the timer, and say when this condition is valid, attribute chance of cloud is less than 40. So if the random number comes out, the random number generated here comes out to 30, that's less than 40, so the cloud will appear. So 40% of the time a cloud will appear. 60% of the time the cloud will not appear because this rule, this condition, is not met. So now my clouds are not as regular. I have some big areas of blue sky, then a couple of clouds, then a lot of blue sky, and then a couple of clouds close together. So I'm using this chance of cloudiness, which is a really, really nice feature to add into your games. So the next thing I'm going to bring in is the mountains. And I'm going to take these mountains and stretch them out so that they're about the same width as my image. Move it over. And I'm going to give it a behavior of movement also. And I'm going to make it a little bit faster than the clouds. I think the whole setup is a little bit too fast, so I'm going to slow my clouds down. And I'm going to make my mountains move a little bit faster than the clouds. And when my clouds get off the screen, I'm going to have them jump back to the other side of the screen. So we got started with this in class, but we didn't finish it. That is a rule. And that rule has to do with an attribute of my mountains. I want to say when my mountain's X position, which really means the center of my mountains, is far enough to the left that the mountains are all the way off the screen. So where is that? Well, the left edge of the screen, as we know, is 0. And the width of the screen is the width of the display. So the mountains, since they're the full width of the screen, will be completely off the screen when their X position is minus the screen width divided by 2. So if the screen is 800 pixels wide, they'll be all the way off the screen when their X position is negative 400. So we'll say the attribute self position X is less than the display size width divided by 2 negative. And this is where I think we had problems before. Negative game display size width divided by 2. Yes, that looks correct. So what happens when the mountains go off the screen? They wrap around to the right side of the screen. So when their X position falls below negative game display size width divided by 2, then we're going to change attribute. We'll change the X position to what? How do we make them jump all the way off the screen to the right? Well, it's the same calculation. It's the width of the screen is the right edge, and since our mountains are the width of the screen and they're calculated from the center, it's half again the width of the screen. So there's two ways to think of this. You can either think of it as the display size width plus the display size width divided by 2, or what's easier for me to think about is the display size width times 1.5. So when the mountains are all the way off the screen, they jump back to the right edge. Now, of course, this is only half the picture, because we also need some more clouds here. So I'll show you a little trick. We bring in some mountains. We bring in our next set of mountains, and actually I'm just going to duplicate. Using Option, click, and drag, duplicate this set of mountains, and only change one thing about them. I am going to, in Graphics, flip them horizontally, just like we did with the fish in our very first example, that flip horizontally attribute. Bring the flipped mountains onto the screen and match them up with the other mountains. And I actually want to make sure that they are the width of the screen. Match them up with the other mountains, and they obey the same rule, the very same rule. So if I did a good job of it, it's a little bit off, but you see our mountain range is pretty much continuous. So if I go here and I make these mountains a little bit wider, and I could figure this out numerically, but it should work just fine by eyeballing it. I've got a nice continuous mountain range. And now we can actually bring our ship into play. Make a new actor for the ship. And our ship is happily flying in front of the mountains with the clouds behind the mountains. We could have clouds in front of the mountains too. Right now they're behind the mountains, that's fine. And as a last step, we're going to bring some of this land in. So now I'm going to create that game functions actor. Put the game functions actor into the scene and have that game functions actor periodically create some land. So I'll give it a behavior of spawn actor. I'll put it inside a 1 second timer. And I will spawn the land actor. So create the land actor, give it the image of land, and our mountains are moving at a speed of 60, so I'm going to have our land move even faster. Give my land a move behavior of 100. And every second, I'm going to spawn some land. Where am I going to spawn it? I'm going to spawn it off the right-hand edge of the screen. How do I know it's off the right-hand edge of the screen? I take a look at my land. My land is 100 pixels wide. So to get it off the right edge of the screen, I need to spawn it at game display size width plus 50, plus half its width. So I'm spawning it off the right-hand edge of the screen. And let's just spawn it at 0 pixels for right now and see what this does. Spawn it at 0 pixels relative to scene. And we get a nice area of land at the bottom of the screen. There's spaces between the land, so I'm going to make the land a little bit wider to cover those spaces. We get 110 pixels. And that removes my gaps between the land. But what we wanted was a landscape that had some variability to it. This landscape is always going to be at the same level. So, inside my game functions, I can create a new attribute, and I'm going to call it land updown. And I'm also going to create a new attribute called land y. Now, what is land updown? Well, land updown is an attribute that I'm going to create to say whether this new piece of land is going to be higher, lower, or the same than the previous piece of land. And I'm going to have that be random. So I'm going to say that my land up-down is a random number that represents the land level going down, the land level staying the same, or the land level going up. Now, this isn't a Boolean, this isn't a 1-0 choice, but it's almost a Boolean. It's a three-way choice. I'm going to say it's a random value between -1 and 1. So they're my three choices, -1, 0, or 1. So the land's either going to go down, stay the same, or go up. So based on that, I'm also going to change the attribute land y. And I'm going to change it to land y plus land up down times 5. What does that mean? Put this in parentheses just to clarify what's happening here. Well, my land starts at 0. So if my random generator generates a land up-down of -1, then -1 times 5 is -5. My land's going to be 5 pixels lower. So it'll be at the y of my land will be -5. If the random number comes up with a -1 again, that means my land drops again. So -1 times 5 is -5. My land was at -5, so now my land drops down to -10. So this combination of choosing a random direction and then applying that direction to the land y will give me a contour, as we discussed in class, it's called a drunken walk, that starts somewhere and goes up and goes down, and then maybe goes down some more, then goes back up. And over time is going to create a random pattern, a random contour. So I'm going to spawn my actor at land Y. And my land can go up or down by 5 pixels. If the random generator generates a lot of -1s, the land level overall will drop. If it generates a lot of positives, the land level overall will go up. Also, as we discussed in class, I can have the direction of the land change based on whether it's going up or down. This also relative to scene, and importantly, my land's motion being relative to scene. I can say the direction my land is moving in degrees is my land up down times 5. So it's either angled up by 5 degrees, I think I can make it even more extreme, 15 degrees, either angled up by 15 degrees flat or angled down by 15 degrees. Oop, that's too extreme. Interesting, but too extreme. So I'm going to make this angled at 5 degrees. And there's still some weird stuff happening in the land. Let me make my land even a little bit wider to avoid that problem. There. Now my land contour is going to be much smoother. And it could go down quite far and come up quite far. I also need to adjust where my land is being spawned now that it's wider. It's 150 pixels wide, so I need to spawn it at game display size width plus 75, plus half its width. There's 2 more things I ought to add here. We haven't seen it yet, but if this goes on long enough, there's a possibility that the land will bottom out and go off the screen. There's also the possibility the land will get too high and be higher than the mountains. So if I want to avoid those things, I can create 2 more rules within the timer. I can say if the land Y is less than, let's say, -100, then, and this is one of those computer things that may be a little hard to wrap your head around, but it's important, the land Y becomes -100. So every time it drops below -100, it becomes -100. So if it goes to -101, it comes back to -100. It just can't get lower than -100. And we can have this same rule. We'll call this the less than -100 rule. We'll also have a greater than 100 rule, saying if the land's Y is greater than 100, then we'll set it equal to 100. So it can't go below -100, it can't go above 100, and that'll set a top and bottom limit on the land. So let's watch our clouds and mountains and land being generated. And as one final note, of course there's no land on the starting screen, which we can fix simply by putting some there. Option click and drag will duplicate. Oops, got to go a little bit further. And a little bit higher. And even a little bit higher yet. And still a little bit higher to get a seamless land transition. There we go. And now our land is going to gently rise and fall randomly, our clouds are going to appear randomly, and our mountains give us a seamless scrolling background. Hope this has been useful for you, and I'll see you in class.